Welcome to the Mathematics and a new video to the MIT Integration Bee 2021. This integral here is from the final round, and it took me a while to crack this. I tried a couple of substitutions. All of them were nonsense, and then I tried the integration by parts, and this will lead you to the goal. So first I want to remember this property from integrals from 0 to a. F of x dx is the same as the integral from 0 to a from f of a minus x. You will not prove it, you can prove this by yourself. It's make an easy substitution and you get this immediately. And then the formula for integration by parts. From a to b, u prime v is uv. From a to b minus integral from a to b uv prime. Okay? And like I said, the first step is, if you want to try this by yourself, integrate by parts, and then make this substitution: x equals tangent of t, and then use the recall 1 to get to the final result. So let's go. So the first step is, if we integrate by parts, we choose 1 over 1 plus x as u prime, and the inverse tangent v. Okay? So we have uv. 1 over 1 plus x is u prime, so integrate is ln, so natural log of 1 plus x times v, inverse tangent from 0 to 1, minus uv prime, so u is the natural log, 1 plus x, over v prime. The derivative of the inverse tangent is 1 over 1 plus x squared from 0 to 1. Okay? If we evaluate this one, we get pi over 4, natural log of 2. Alright? And the second integral, I call this j, so minus j. And this maybe I call I. So and now we can take care of the second integral. So let's see. So j is integral from 0 to 1. So now if we make the substitution x equals tangent t, I leave the details for you. What we get is integral from 0 to pi over 4, natural log 1 plus tangent t. Okay? So here we make the substitution x equals tangent t. Okay? And then you get, dx is 1 over 1 plus and so on. Okay? So I leave the details for you. So this is also j, of course. And now what we do, we apply our recall here, and therefore j can also be written as from 0 to pi over 4 of natural log 1 plus tangent a is pi over 4 minus t dt. Okay? Now if you use the tangent addition formula for this one, Also, this is an exercise for you. If we apply the addition formula to this one and we simplify a little bit, we get integral from 0 to pi over 4 of ln 2 over 1 plus tangent t dt. Alright? And now we have two expressions for j. This one and this one. So the borders are the same. Now if we add them up, maybe you see what happens. If we add them up, we have, because the integral is linear, we have the sum of two logs, and therefore we can write the two logs as one log and we multiply the arguments. Okay? And you see this cancels out. So what we get is 2j is integral from 0 to pi over 4 of natural log of 2 dt. How beautiful is that? Also here, write that down, add them up, and you see that the tangent cancels out. This integral is very easy. This is just a constant, so we get pi over 4 natural log of 2. And because here we have 2 times j itself, if we divide by 2, j itself is pi over 8 ln of 2. Alright? And now we had also our first equation. We had from star we had I, this was our final goal, is pi over 4 ln 2 minus j. And now if you subtract these two values, we see that our final integral, so pi over 4 minus pi over 8 is pi over 8. Pi over 8 ln 2 and this is our final result. So the extreme left hand side was exactly our integral, and now we are done. Pretty nice integral in my opinion. Like I said, it took me a while to come up with the integration by parts, and then the substitution is also very tricky in some sense, and this property sometimes useful, for example in this case. I hope you liked it. See you next time.